but the new game is 2090. Is this year's? You know,
Yeah.
it's a
Yeah, I
it's a
understand.
big,
Yeah.
yeah.
Oh, maybe I'll try it. You
Maybe
think it's
you
perfect?
Can, yeah, maybe you can tell your friend.
Okay, maybe. Maybe.
He must be very thankful for you.
Okay.
Yeah.
Maybe I'll look at it. Right, are you ready? Go, Ben. Did you have something to eat?
Oh, very small for cigarette outside.
You didn't eat anything.
No, it's not necessary for me.
Right.
Yeah, you feel small, you don't feel hungry.
Yeah, it's like this.
Okay.
If you want to lose some weight,
You smoke.
yeah.
Okay.
It's a good idea to lose weight.
Yeah. All right, let's continue. Photons now.
What?
Like photo? Actually, yeah, like photos. Yeah. Yeah.
Oh, I like the shawarma.
Oh, you had it yesterday.
It's
Good.
very, very nice.
Oh, yeah. Yeah. I'm going to text Joan and tell her, because I told Joan Ben had the shawarma, and she said, why? That's too much food for him. Was it too much food?
No. Oh yeah, it's too much,
But did you finish it?
yeah.
I'll say Ben said his lunch yesterday was great. Did you finish it all?
Yeah.
And he ate it all.
Who?
Joan. Because she said, why did you tell him this? It's too much food. And I said, no, not too much food. So, will you eat it again?
I will try the this one. The corner is here.
Oh, the other place.
Yeah, I will.
Yeah.
You say the chicken.
The chicken place, yeah. Okay, photons, have you got that? What's so funny?
My account, my bank account
Yeah.
left
0?
€19.
That's okay.
No, I didn't change yet. I didn't. I have a Chinese money.
Oh, okay. 19 euros is enough. You can get lunch. You can get lunch for €6.50.
Yeah.
What drink did you have with it?
No drink, I take away.
Did it not give you a drink?
Yeah, no.
What? But the drink comes free.
Maybe you should ask.
Yeah.
I won't listen to your recommend again.
Was my recommendation good yesterday? Did you like what you had yesterday? Yeah?
No, I won't listen to you.
He liked it.
My stomach is too soft, you know.
You smoke too much. That's your problem. Yeah.
No, if
Ben's a good student. He doesn't smoke, right?
the problem is that
Yeah.
It's European and Asian. Is that
No, the
stomach
problem
is
is you're,
different?
no, the problem is you're smoking too much. That's the problem. Right, photons. So we have a lot to do. Okay, so firstly, quantum. So does anyone know this word? Huh? You heard of it? Yeah. I wouldn't be surprised. There's some movies called it. Yeah. What do we think it means?
I know quantity.
movie.
You know what?
Quantity.
Yeah. So it's related to quantity. Could be to do with electricity. Quantum means, or quanta.
It's like square, 3 4 4.
No, it's not this. No. A quantum is the minimum amount, or as you said, Gao, the minimum quantity. It's the minimum amount involved. So look, I'll give you an example, okay? What would be a simple example? When you buy a shoe, shoe sizes in China, What numbers are they? Are they big numbers or small numbers? Like what's...
Big number.
Like 37, 38,
Could-
40.
Okay, could you get like 37 and a half?
Yeah.
Yes.
Could you get 37 and a quarter? Probably not. No. So you would say that the quantum is a half. Because you can only get halves in the shoe sizes. Right?
Yes.
You can't get 37 and a quarter. You can only go in halves, yeah?
Yes. Why we don't say just half?
Yeah, but what I mean is the quantum is a half.
Yeah.
The smallest amount,
So after the point.
or before the point, is
So-
whatever
so-
the smallest amount is.
So we can't get less than quantum.
Exactly, exactly. So for example, money. What's the quantum of money? Or well, what's the quantum of money?
So 5 cents.
No, you can get smaller than 5 cents.
One.
Well, okay. In some places you can. It's
Like
1 cent.
1 cent, yeah.
But in some places it's 5 cents.
Cents.
Yeah, do you understand?
Yeah.
You can't go in
Done.
and get half a cent,
Oh.
right? So quantum just means the minimum, like you said, the minimum amount.
So can we say like number like 1.5?
1.5 could be the quantum, yeah.
So we
And-
can't say 1.25.
If it's 1.5,
Yeah.
you can't say 1.5, you can't say 1.49,
Yeah.
you can't say 1.48.
Oh.
You look so confused.
I understand the meaning in English,
Yeah.
but I didn't get the real meaning. Maybe
Well,
more example.
we haven't talked about its meaning in physics yet. Because you see here I say, so far we had no need for quanta.
Okay.
Because, for example, how long is this pencil? Maybe 15 centimetres.
Mm.
Could it be 14.9? It could be. Could it be 14.01? Could be. Could it be 14.00002? It could be. We've no need for quanta so far. Okay? For example, we don't have a quanta of distance. That is, there isn't some minimum distance. You could have 1 centimetre, you could have 1 millimetre, you could have 1 micrometre, you could have 1 nanometre. You know, distance can be any number, right? Okay. So first, did you write this box down?
Yeah.
They didn't. There's another word in English that has a similar meaning to quantum. Can anyone think of another word that might have the same meaning?
Limit?
It's kind of like limit, but not. So you can, in a moment, you can check your dictionary. Wait, just a minute. So you can look up quantum. But another word in English which is like it, if I can spell it right, iota. Now, I want you to check both these words on your dictionary.
Quantum mechanics.
Mm-hmm.
I know this.
Aha.
And did you look up this word?
Yeah, that's like that's not that academic.
Yeah, it's not academic, yeah. Okay, so we have a good understanding of this word now? Yeah, Ben? Okay, let's continue. Right. So what is a photon? Now Ben said something or maybe it was Gao, I don't remember. One of you said photon is like, which word in English?
Photon.
It's like photo. Yeah, it's also like proton, yeah. So, it's most like photograph, photo, P-H-O-T-O. So, it won't surprise you that photon is related to light. Because, you know, photograph, take a picture. So photon is about light. A photon is a single quantum of light. So in other words, it's called a light quantum. It's the smallest amount of light that you can have. It's like the minimum piece of light, the smallest amount. Do you understand what I mean? You don't?
Yeah, I understand your meaning, but it's very strange. So
It is.
So
the
what's
length
that?
of the light.
It does a limit.
Yeah.
Yeah, there's a minimum.
So what's that work for?
Huh?
What's that work for? Used for
What's what used for?
piece of light? You say the meaning.
Ah, yeah. So we'll see why it's useful now in a moment. But it's kind of like, you know, in chemistry, you have mass, and then at the bottom, you have atoms as like the smallest piece. It's kind of like that. You have light, and then at the bottom, you have the smallest amount of light, which is called a photon.
What visual thing?
Yeah, I was about to say that. So, in chemistry, you know that things like this table are made of many atoms. Many, many atoms. So, likewise, the light, we should think of it as many, many photons. On your phone, the radio signal is many, many photons. The light from the sun, many, many photons. That's how we should think of it. Like we think of the table as many, many atoms. Yeah. It's okay? Yeah. So look, you can have some distance. Then you can have you don't have to write this down. I'm just making this really, really, really clear. Small distance, smaller distance, an even smaller distance, even smaller distance, even smaller distance, even smaller distance, no smallest. Agree? Agree. Okay. So, compare. You can have some light, smaller light, smaller light, smaller, smaller, smaller. Then you have the smallest light wave, a photon. And what's smaller than this? Nothing. You understand what I'm saying? Yeah? Okay. So, a photon of light is like an atom of light. That's the idea. Good. Good. There's nothing smaller. Right. We're happy with the idea? Right. So, what is a photon? Like, what is it exactly? It's kind of like a particle. Yeah, it's like an atom. It's like a little particle of light. So I think it's good if you can write at least this. It's a particle of light. It gets more complicated, I promise.
So can we say lights?
Can you say what?
Lights. L-I-G-H-T-S.
No, but you can't say photons.
Oh.
Yeah. The reason is, in English, light is uncountable.
Yeah, I know.
So you can't say lights. Yeah. Okay, continue. It was Einstein who discovered the photon. You know Einstein? He discovered the photon. And he also discovered that it depends only on the frequency of light, that the energy in it. So I'll explain here with a picture. Now this is very strange, okay? So imagine you have an ocean wave here, and you have a ship on it, a boat. And here it is here, like this, okay. So this wave here, if you look at the wave, it has a few things. It has an amplitude. It also has a wavelength, lambda. It also has a frequency, you know, things like this. This wave has energy in it. And you know it has energy in it because if you're on the boat, you will feel the boat moving. So this kinetic energy comes from the energy that's in the wave. My question is, what do you think is most important for the energy? If I want to make more energy, which do you think is the thing that's most important? So I want the boat to have more energy.
The frequency.
The frequency.
Yeah.
What about the amplitude? So on the boat, what about if the wave was like this?
Wow.
More or less energy?
More.
Yeah. So you could say that the frequency is important, but the amplitude is important as well.
So they're
'Cause-
the same.
Well, for the water you need to know both, really. Because, okay, you're right, if the water is moving very fast,
Yes.
that makes more energy. But if it's moving very fast and is very big,
It's more.
it's more, even more. Okay. What Einstein discovered for light is actually only really important what the frequency is. So Einstein discovered that the energy depends on the frequency, or you could say that the energy is proportional to the frequency. Now you kind of know this already. Remember in semester 1 when we did our chart, in the middle we have light, and down here we have X-ray. Do you remember this? And down here we have radio. Yeah? And X-rays are like this, and radio waves are like this. Okay? And here the frequency is high, and here the frequency is low. Which can hurt you? X-ray. Which will not hurt you? Radio. And the reason for that is because this has more energy than this. And the reason this has more energy is because the frequency is higher. So do you remember what the light is called here that comes from the sun that can hurt you, hurt your skin? Remember what that's called? The light that hurts your skin? Yeah, UV.
ATS.
Not UV ATS, but yeah, just UV. So if the frequency is more than this, it hurts you, it's harmful. And if it's less than this, it's not harmful. Remember we did this in semester 1? Yeah? Okay, so anyways, that is, the higher the frequency, the more energy. So there's a very simple formula. The energy in the photon is equal to h times f, where h is known as Planck's constant. And the value of h is quite small. It's 10 to the minus 34. So a little bit of light has a little energy in it.
I already got burned on the skin.
Here or in China?
No, in Turkey.
Oh, in Turkey. Oh, yeah, okay.
It's tortured.
Your skin is not too light. It's a little dark.
Yeah,
Yeah.
but actually here, like,
Is light?
it's more tense. And it
Ah.
burns now. It hurts me.
So you were wearing shorts
Yeah, of course I
and
was
t-shirt.
swimming.
Yeah. Ah, okay.
And when I get on the boat, I'm still wet, so I'm lying there and I didn't put
You got cooked. Yeah.
kind of, and I didn't put the sun cream.
Ah, go.
No,
Ah.
because my friends told me that would be pollution for the sea, so we can't use this. And then
Your friends are crazy.
I'm
Your friends
lazy.
are crazy. Terrible. Terrible. You got that? Now,
Yeah.
you use this used to be done in chemistry class, but not anymore in the old IFY. So I'm telling you that this formula is actually important in physics and chemistry. So if you study chemistry next year, you will probably see this in your chemistry class. If you do see it in the chemistry class, the chemistry teachers use a different symbol. So in physics, I like to use HF. But some physics and chemistry teachers, they write it like this. H nu. And this is a Greek letter, nu, and it has the same meaning as F. I think you should make a note of this. Well, are any of you going to study chemistry next year at university? What are you studying?
Maybe DCU, maybe
Yeah, but what subject?
maybe computer science.
Ah, no, okay.
Maybe electronics, computer
No,
system.
no.
because my first year is general engineering.
Hey, so you might do it in chemistry class. What are you studying next year?
Information technology.
Okay, so in architecture. Okay. Maybe you'll see this next year. Okay.
Lauren we were talking about frequency. She just used app.
Yeah. It's common enough. Okay, so here's a simple little question. A photon of red light has a wavelength of 400 nanometers. So if you can picture this, you have one little photon of light, and it's moving along. There it goes. Just one photon, and its wavelength is 400 nanometers. And my question is, how much energy does it have? Okay? Use the formula, tell me what you get.
But so it's no matter if it's red, if it's color blue, red.
The only thing that matters is the frequency.
Oh.
Frequency.
So frequency
Oh,
equals
is that lambda?
V or lambda?
Yeah.
So it's
That's lambda.
Okay.
so what's the
It's on
400
Wait,
times
wait.
6 minus 3?
Oh, a nano, minus 9.
Oh.
But where's the V?
Ah, you forgot so much.
Long
Who remembers the formula for V? V
frequency.
equals lambda F.
Yeah, but what is the V?
The V is C, because it's light.
What is?
What? Oh my goodness, you don't remember anything. 3 times 10 to the 8.
Okay.
Look at that face. He's shocked. Oh, so I don't forget to tell you, because you'll not need to know this. Today is Burger Day.
burger.
Yeah, so some places in Dublin have a special offer. You can buy 2 burgers for the price of 1 burger.
Where?
You can check the website. Just go to Google and type in National Burger Day. You can get a list. Look, he's already checking now.
It's -9.
It's
Um,
-9.
Is 3.31 times 10
Okay.
minus 90.
So you wrote this.
90.
90. 90?
19.
19?
19.
Okay, that's pretty small.
Minus 90.
F is C over lambda.
Yes.
So what did you get then, sorry?
3.31 times minus 19.
Now, that is quite small, isn't it? What is a better unit to use when it's small? Not joules. EV. So can you give this to me in EV, please, now?
Is the answer over
Over.
6?
Summer, you can look at your burgers after class.
Times 6.02 times 10 or
I'm sorry, Ben, I don't remember. It's on... I got a message from Joan. Look what she said.
I got same idea.
I said, same idea. I said,
I don't have these.
sick idea.
she sent me a message saying, did you tell the students about the burgers?
Oh.
I have the answers about the
Yeah, but
EV, but I don't get the numbers.
Yeah,
I don't have-
same. But I remember I got the EV class, but
Yeah.
which one is that?
oh my goodness, it was the less. Oh goodness sake!
It's very strange.
I'll tell you now.
Electric field per 10.
I'll tell you now. There. Yeah, electric field potentials. Convert into joules, convert into EV. Did you get it yet? No, look, guys. It's taking too long. Just take out your phone and in Google type in charge of electron.
I think only is to
Here, I'll write it down. Wait, listen to Summer. E equals.
1.6202
That's
and the 10 minus 19.
good.
Must write it down.
No. I want you to write it at the front of your book, okay? Put it somewhere at the front, all right? Did you divide by this?
Oh, it's bracket. Stupid.
Okay,
I think it's
right.
Really?
And V is the C.
Coulombs. Yeah.
So wait, E multiplied V.
No. Oh, Gow. To convert this into electron volts, you divide by E. You know this. You know this. Right, what do you get? It should be a small number, I think. Should it? Should be like 2 or something, is it? What you get? No. No.
Yeah, no.
No. It should be like 2 or something. Go, did you get an answer?
No.
Come on, this is taking way too long. Come on, 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 come on. Guys, stop, look. Look, this, look. This and this will cancel.
Yeah.
It's just 3.31 divided by 1.602. What do you get?
2.2.067.
Thank you. Okay. Okay. So, the red photon has 2 electron volts of energy. Okay? You don't have to write that. Is it okay? So, let's continue. What is the frequency? How much energy does it have? And joules and EV. Okay, we've done all of that. Right. Your mobile phone operates at. Are you looking? Your mobile phone operates at an electromagnetic frequency of about 900 megahertz. So that means on your phone, here's my phone.
How about the burger?
We'll get to that in a moment, okay? So the wave that comes out here has a frequency of 900 megahertz, okay? So there's lots and lots and lots of photons, and they're going, the frequency is very high. And the power of your phone, the power output here, the power is 4 watts, roughly. How many photons are coming out of your phone per second? Okay, so look at it like this. You know power is work over time. And if we're only looking at 1 second, then what is the work? Or in other words, the energy? Is equal to 4 joules. Okay? So, all these photons in 1 second, all the energy is 4.
Wow.
Okay? Now, what's the energy of 1 photon? HF. But that's only 1 photon. We have, let's say, n photons.
So we calculate the F?
Yeah. Well, and also we should multiply this by n. Okay? So can you calculate n? Yeah, because we know h. And can we know f? Yeah, because I'll tell you f. So you can calculate how many photons come out per second. How many photons come out of your phone in a second? Calculate and see how many it is.
So what is TOT?
Oh, total, short for total.
Proton is N?
Photon,
Photon is N?
any letter.
Oh.
Can we just use like 6.6? That's too long.
Is 10th, 10th 9?
6.
Omega is 6.
6.7, 10, 24.
That's a lot of photons every second. So when you're...
Yeah.
It's a big number.
1,
Go,
2, 3,
go,
4,
Go!
5, 6, 7, 8, 9.
Where is your calculator? Did you lose it? Is it in Turkey? Where is it?
It's not useful.
Will you please buy a Casio calculator?
Yeah.
You need it for the exam.
Okay.
Right. Is this okay? So think about this. When you're on your phone, that's as many, all the photons that hit your head
Yeah.
in 1 second.
We will die.
No. The frequency is too low.
The frequency. What is too big?
No, what I mean is it's not big enough to hurt you. Mega is safe. This is safe. Yeah? Continue? Continue? Okay. Right. Electrons on the surface of a metal are trapped. They require energy to be freed. So, let's take a piece of metal. Let's say, won't be a good metal. We'll just say it's gold. Okay? You know from chemistry that there are lots of electrons moving around here, right? Just moving around. Lots of electrons in a metal. You learned this in the first week of chemistry, okay? But these electrons, they're trapped. They're stuck on the metal, okay? And if I want to free it, I have to give it some energy. So for example, like this here is trapped on the table, right? If I want to free it, I have to give it some energy. Okay? So, because it's trapped, the potential energy, we know something about the potential energy if it's trapped. We know it's what? No, that's for a different situation. We know that the potential energy is negative if it's trapped. Remember this? Yeah? So, has negative potential energy. The energy required to free the electron is called the work function. So, what I mean is, let's say the potential energy, we'll just make up a number, we'll say it's minus 2 electron volts. How much energy must I give it to be free?
2.
I must give it 2. So we call this here, is called the work function. And we use this symbol. In this example, the work function is 2. Meaning we must give it 2 electron volts to free it. Wait, no, you can have the definition here. The work function is the minimum energy needed to remove an electron from a solid to outside the solid. In other words, is the energy you need to free it. This must be Joan again. Oh no, postman. You got that? You got that? Somewhere?
No. Yes.
No. Okay. So, go. You got it? Okay. When photons strike a clean metal surface, it will cause the release of electrons from the metal surface, if and only if the photons provide enough energy. Okay, so here we are. Here is the electron, and here is the photon. And the photon, you know, has energy. Yes? Ben? What are you just checking?
To smell the burger.
No, later. I will show you it later. Later. Okay. Can we listen to this, please? I shouldn't have told you this. I should have told you this later. Right. So the photon has energy, and when the photon hits the electron, the photon can give the energy to the electron. What's the formula for the energy here? It's HF. Okay. If the HF is bigger than or equal to the work function, what will happen to the electron?
Stable.
It'll be free. Because it gets enough energy so it can leave. But if the energy in the photon is less than the work function, what will happen?
No change.
Yeah, it'll still be trapped. No change. Okay? So, when the photon hits the metal surface, it will cause the electron to be released only if the photon provides enough energy. This is called the photoelectric effect. So here, this is called the photoelectric effect.
This
Photo.
sounds really chemistry.
Yeah. Well, remember I said that this topic is in chemistry as well. So when this happens, we call it the photoelectric effect. Now, the reverse is also true. So watch this. You'll find this interesting. Here is the metal. Here is an electron. I throw the electron on the metal, and the electron sticks to the metal, and guess what happens? A photon comes out. So, you can also do it backwards. You can throw a photon and release an electron, but rather interestingly, you can throw an electron on the metal and release a photon.
You also need
You need the right energy, yeah. So you also need this has a kinetic energy. Yeah. So you need to make sure that the energy is enough as well. The kinetic energy. So here I'll just make it for the moment. I'll just make it equal, just to make it easier. If it's equal, and here the kinetic energy should be equal to the work function as well. Yeah. Well, okay, no, I'll make it more than. Sorry, it's more than. And here also more than. So I think that's very interesting. I think you can all understand if this is an electron and I throw some light on it, I can free it. Makes sense. What's so strange is if I take an electron and throw the electron on the table, a photon comes out. Where did the photon come from? You know, it's not like the photon is inside the table. It's not like if I open the table I can see the light inside it, right?
Yes.
Like, where did the photon come from? You know, it's interesting, right? Right? Yeah, I think it's interesting. So the reverse is also true. When an electron strikes a clean metal surface, it could release a photon. Yeah. Okay, so I think you don't have to draw the picture, but Yeah, if you write this box down. See, I know, you're thinking about your burgers.
No, we have ours.
Yeah. Yeah, don't worry.
One.
I start hungry.
You see, this is why I gave you a breakfast break, so you could have food.
But I also.
Because we use our brain. Yeah?
Yeah,
True.
it's true, yeah.
Oh. Do you think how many IQ Einstein had?
Einstein? Oh, I'd say it's
160.
pretty high.
160, yeah.
Is it?
Can't remember.
It's
Could be
more-
160, yeah. 150, 160.
It's one. Such.
No, don't, it's okay. It's not important, he's dead.
But he's still smarter than us.
Probably. Is it 160?
Yeah, right.
Yeah, he's probably smarter than us. Probably. I don't know, maybe one of you have an IQ of 160.
Is that IQ like base us when the people growing up?
Yeah, it seems to be the same for your life.
But you said if the people don't go to college, maybe they are less than us, less than the.
Most
Yeah.
of that is, but some people I know in my high school,
Yeah.
they don't do homework and don't listen to the
Yeah.
teachers, but
They do well.
yeah,
So that
they can understand the.
that means they probably have a high
Yeah.
IQ.
Yeah.
Go. What I'm saying is, you're born with your IQ, and if you're lucky and you're born with a high IQ, it means you'll probably go on to college.
Okay. Oh, that's been.
Oh,
Yeah,
some-
because there's lots of people in China, like they skipped the
Yeah,
grades
yeah.
in school.
Yeah. Well, I think if you look at countries in the world, the countries with the high IQ is China, Japan, Korea.
Oh, really? Asian?
Yeah. So congratulations. You're lucky to be born in a country with a high IQ.
But Chinese use IQ in the same.
Chinese, yeah. Like, Ireland IQ is a little bit lower. So I think in China maybe the average is like maybe 105, 110.
It's the highest.
In Ireland the average is 95.
So highest maybe is a Jewish.
Correct, yes, you're right.
Yeah.
The Jewish group have the highest IQ
Yeah,
recorded.
I think they are very smart. I don't know.
Yeah.
I don't know what.
Well, it's interesting when you see lots of famous people on TV who are very smart. You discover that a lot of them are Jewish. You know, I'm thinking like, well, you wouldn't know these people, so there's no point. But I'm sorry to tell you, Gao, that you're born with it.
Okay.
And so by the time you're 7 or 8 years old, you can already guess if the person will go to university, because you can know if they have high or low IQ. So you can't make your IQ bigger. You can only make it smaller.
Oh, okay.
Yeah. How do you make it smaller? If you eat badly, if you drink too much. No, it's true. If you drugs, drinking, too much eating, you can make it lower. Can you make it higher? No. You can only make it lower.
So there's no history or no proof like anyone can
No.
have.
No.
But what's that data came from?
It's been
About
studied.
IQ?
It's been studied for 100 years. So it's quite well studied, you know.
Okay.
You should do a test sometimes to see what it is. I paid like €25. You can do a test in the city centre because I wanted to know what it was.
But it's
We have lots of like
but it's-
websites to do.
They're no good.
yeah.
They're no good. They're no good because I tried the websites. They're not accurate. They're not accurate.
But it's in English.
No, there's two tests. There's an English test and a picture test.
Oh.
Yeah,
€25.
yeah.
No. It's
No,
not
it's
worth.
not, okay.
It's not worth.
It's not worth it. Okay. Okay. Right. So, just a little bit of vocabulary. This in word intensity. Like, if the light is very bright, we say it's intense. Do you know this word in English, intense?
No.
No, you don't know? Do you know this word, Gao, intensity? No, okay, check your dictionary, intensity. You know, you obviously know this word. Check this, intensity. What do you think it is? I know, check it. Okay, check it.
I know this.
I know
We learned
that.
this before, isn't it?
Hmm?
We learned this before.
Did we? I don't think we did. Maybe.
Stephen, you just said that means it's very, very bright.
Very bright.
Very
So,
bright.
yeah, it means...
But it's low intensity. You said.
Okay, I'm
intensity
sorry,
is very-
the English is messy here.
Yeah.
If I use the word intense,
Yeah.
I mean it's very bright.
Yeah.
If I use the word intensity,
Yeah.
wait, just listen, please. If I say intense,
Yeah.
I mean very bright.
Yeah.
If I say intensity,
Yeah.
I can change the amount by putting a word in front of it. So I can say low intensity, high intensity.
Yeah.
But if I just say intense,
Mm.
I always mean high.
Oh.
Grammar. I'm trying to think of another example. I got it. You could say something like, you know, he is very tall.
Yeah.
You could say he's not very tall. No, that's not a good one. I can't think of a good one.
He is high and he.
You can't,
is
yeah, no, you
little-
can't say high though
Yeah.
in English. It's similar, anyways. Okay, so look, first one here, low frequency and low intensity. So low intensity means dim light. It's not so bright. It's kind of dark, right? So, what will you have? If you have low frequency, does that mean a lot of energy in the photons or not much energy in the photons?
Not
Much.
much.
Not much energy. And low intensity means the light is kind of dark, yeah?
Yeah.
That means not many photons. Okay? So if you have low energy and not many photons, what you get is some freed electrons, but low kinetic energy. Now what's the story with kinetic energy? So remember we said that the HF needs to be more than the work function. Where does the extra energy go? The extra energy goes into the kinetic energy. So for example, suppose the work function is 2 electron volts and the light is 20 electron volts. Then where did the extra 18 go? Because you only needed 2 and you had 20. Where did the extra 18 go? It went into the kinetic energy of the electron. Do you understand? So, if this guy needs 2, and this is 20, then the 20 comes down, gives this 2, and then the 18 continues as kinetic energy. Yeah? So, if it's low frequency, then it's low kinetic energy. And if it's low intensity, it means you only have some, not many, some freed electrons. Okay? Now, maybe you can tell me the next one. If it's high frequency and low intensity light, what will you get? High kinetic energy and many or some?
So,
Yeah, good. Some freed electrons of high kinetic energy. Okay? Low frequency and high intensity. bright light.
So many free electrons.
Many free electrons and
Low
Low
kinetic
high frequency and high intensity.
many higher.
Many free electrons of high kinetic energy. So these are like the 4 situations.
Should we draw this?
Ah, don't forget about the pictures. Pictures stupid.
But that's you.
No, I didn't draw it, and I need a better picture, anyways. Yeah? It's okay? Yeah, I think you all got the idea here. Right, so we have a formula here. We can think about it on the picture. So let's look at the picture here. Here is the photon and here is the electron. And then afterwards we have just the electron. No photon. Okay. If we look at this picture, what is the energy of this photon? What's the formula for it? It's HF. Okay. And what is the energy of this electron? Go. Are you on your phone? Go! Turn your phone upside down. It'll make me feel better. Okay. Now, as I was saying, the energy of the photon is HF. What is the energy of the electron? That's trapped. Oh, come on, guys. No, minus work function. Yeah? No, you're making that face that either says I'm hungry or I don't understand.
Both.
Or both. Okay, so this has energy HF. Yes?
Yes.
Okay. This is trapped. It has energy of minus work function. Is negative. So the total energy is HF plus minus work function.
Yeah.
So that's HF minus work function. In this picture, what energy is this? This is kinetic energy. Right? But the conservation of energy says the energy at the beginning must equal the energy at the end.
Yes.
Energy cannot be created or destroyed. So we have this formula. Yes? And we usually write the formula like this, so it's positive. is usually how we write it.
So they will give us work energy.
They'll either give you this and want that, or, they might, usually what they do somewhere is they give you this and they give you this. Is it okay? Are you sure? Okay. Look at how hungry you are. You no breakfast, 4 cigarettes, and that's it. I shouldn't have given you a breakfast break. You didn't have anything to eat. And are you hungry?
You shouldn't tell us the burger. 2 burger.
2 burgers. Just keep dreaming about it, okay?
Is the chicken place has the...
No, they don't have the offer.
Why?
They didn't want to do the offer.
Oh, it must be a famous
Yeah.
restaurant.
I'll tell you which places later. Don't worry.
One guess.
Yeah.
KFC.
KFC.
I don't know.
KFC is not popular here.
Okay.
McDonald's is more popular.
Okay. I think I know 2 places. You can check on your phone later.
Okay.
Okay, and I'll tell you the 2 places, and then we're continuing with this, okay? Goodness sake. Right. You guys drive me nuts sometimes. Okay. So look, here's the first place.
It's nearly...
Here's the school,
Oh, yes.
and there's a place at the corner here,
What?
a pub.
It's a bar.
It's a bar, but they have food as well. They have a restaurant area, food area as well, okay? It's called the Headline. And I think they have the offer. 2 burgers for 1, I think, okay? Now, if you continue down this street and then turn down here
Oh.
onto Camden Street. You know this street, Gao, don't you?
Is AIB?
Yeah, the AIB is like here, yeah.
Yeah, it's the...
It's
Yeah.
24.
There's a place down on this side called Eddie Rockets.
Oh. Yeah. I know.
Me, Joan, Sylvia, and Colin are going there today.
Oh.
Okay?
But we only have 1 hour break.
Yeah, so we're going on our bicycles. So we're going to cycle down and get our burgers.
Unfair.
Wait, hang on, you can go to this place.
How to, lock the bicycles?
There's bike locks on this street.
Okay.
Yeah,
Oh.
bike stations. What? Yeah, he can get them for you and deliver them. He has a bicycle.
But
Is it only Rapids or only this one?
All Eddie Rapids.
Be late.
Huh?
We have the new class. We can't be late.
Bring him a burger. Tell him, sorry I'm late, teacher. I was buying you a burger. Here you go.
God.
Yeah?
Oh my god.
Okay? It's my tip. Right. Happy now?
Yeah.
Okay. You got this formula? Yes? Okay. Right. Do you know the Nobel Prize? Do you know this prize?
Yeah.
You know the Nobel Prize?
Yes, the...
Yeah. Famous prize. You know this prize? What's it in Chinese? Tell them in Chinese.
Nobel.
Okay, it's the same word. Do you know this prize? Okay. You might think that Einstein won this prize because of this formula.
Because the burger.
What?
Yeah.
Because the...
Yeah, Einstein did not win because of this
Wow.
formula. He won the prize because of this formula. This is why he won the Nobel Prize, because of this formula. Not
Wow.
this formula.
Why? But this...
This is famous though.
This is more famous, yeah.
Sun...
But this was more surprising.
Oh.
Is more. Remember, I was saying it was interesting how the electron can make the photon. that was more of a shock than this formula. Yeah.
Okay.
So
But you say the MC squared, the C has 3 and 4 page.
yeah.
It's more difficult.
Yeah. But this is more surprising.
I don't think it's more useful than.
No. You win the prize for discovering something strange and different, not discovering something useful.
Oh, okay.
The Nobel Prize isn't about discovering something useful, it's about discovering something different. Do you understand? Yeah? Okay, so, I think that's interesting. Right. The work function for copper, you know copper, Cu, is 4.2 electron volts. A photon of wavelength 250 nanometers hits the metal. After the photon hits the metal, an electron is freed and travels at the speed v. Okay, first question. What is the work function in joules? Please convert this to joules.
It's tens. Sometimes it's okay.
No, you wrote it down at the front. Remember I made you write it down, the E.
Yeah. No, it's 4.7 tens.
Yes.
It is 7.5 times 10 minus 19.
Okay? B. Oh, the reason I said to do this is because in the formula you must use joules. Okay, B. What is the speed of the electron? So you can now use the formula I just showed you. Where's it gone? What was it? HF equals H equals work function plus KE. Okay? So, what do we know? Do we know the work function? Yes. Oh, sorry, I wrote the wrong letter here. This is a work function. Right. Do we know H? Yes. Can we know F?
Yes.
Yeah. Here, you should change this into a half mv squared because I want the v.
Yeah.
Oh, we don't know that.
Ah, but this is the m for an electron, which you have it in your notes.
Oh,
Right, calculate the v now, please.
it's the N.
Oh, sorry. 250 nanometers is the lambda.
215 M.
Here, Dan.
M. So it's
Nanometer is minus 3, minus 6, minus 9.
9.
Minus 9 for nano. an answer, Ben? So you can say this is hc over lambda equals work function plus a half mv squared. So hc over lambda minus work function equals a half mv squared. Can multiply by 2, divide by m, and then square root. So the v will be whatever square root 2 hc over lambda minus work function over m e is. So the theta?
Yeah.
The phi?
The phi.
It was...
7.5.
Sorry, yeah, let me see. 7.5, yeah.
I got 2.7 multiplied 10 of power of minus 35.
Minus?
35.
No, that can't be right. That's too small. The electron should be going, fast. Oh, because you're using your phone. Let's see. Whoa. Now that looks like it, Ben. Yeah, good man. 3.12210 meters per second. So it's 312 kilometers per second. Yeah? Skip 4. Alright, is that okay?
Okay.
Is it?
Yeah.
I think you need to buy a calculator. Right. This is a normal exam question.
Wow.
Okay? It's a normal exam question. Right. Threshold frequency. The work function means... Okay. Blah, blah, blah. Let me explain. No, actually, I can go back to where I talked about it earlier. Whoa. Where'd it go? Up or down? Here. So you remember earlier I was saying that HF needs to be more than the work function. And the extra energy, where does it go? KE. Yeah? If you don't want extra energy, right? If you just want the electron to be free, but not to be flying away fast, you know what I mean? Just to be freed, then you need the KE to equal, or at least roughly be 0. Okay? So you have HF equals KE plus work function, but if this is roughly 0, then you have HF equals work function. So F equals work function over H. This here is the minimum frequency, F0. We call this the threshold frequency. It's the minimum frequency required.
Double L.
I don't think so. 1L. Threshold. Do you know this word in English? I'll give you an example.
I know trash.
You know, but that's T or ASH. That's different. I'll explain it.
I know rush.
No, not even close. I'll explain it. Ben, what grades do you need for your university choice?
C, B, C, C.
Okay. Go. No, listen to me and you will learn. Ben needs these grades. If Ben gets, for example, B, 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 will he go to university? Yeah, because they're more than or equal to these grades. So these grades are the minimum. The minimum to get in. In English, we call that the threshold. Example, remember earlier somewhere we were talking about Mensa.
Yeah.
You could say the threshold is 130 IQ.
Okay.
Do you understand this word?
The
Yeah.
lowest requirement.
The least requirement. Yeah? It's a good word to use in English, you know. You say, what is the threshold for getting into university? You know, in Ben's case, it's 3 C's and a B. Yeah. Okay. So, you wrote this formula down? Threshold frequency? Yeah? Okay, good. So, what I want to do, let's do a calculation. What did I say the work function was for copper? We had it earlier in the last example. What was the work function?
4.7 E.
Yeah, what was that in joules?
7.5 and 10
That's
of
kind
minus
90.
90.
Joules. I want to know what is the threshold frequency. Give me that, please, here.
Always. Times 15.
10 to the 15
15.
hertz. 10 to the 6 is mega. 10 to the 9 is giga. 10 to the 12 is tera. 10 to the 12. What? 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 Anyway, it's fine. It's this, yeah? It's okay? Yes?
Oh, it can hurt us.
Huh?
It can hurt us.
I'll tell you, let me think. I'll tell you what the frequency is that can hurt you. If you just type into Google, what is the frequency of UV?
My phone is too slow.
What did you get as the answer here? Khalifa, did you type this in? So it's around about, yeah, around about 10 to the 15. It can be about 10 to the 14 to 10 to the 16. So I would say, Summer,
Yeah.
as soon as you have 10, Summer, please, don't make me tired. As soon as you have 10 to the 15, I would say this is when it becomes dangerous. So, to answer your question, yes.
So, what is the the fast frequency can break where brain or ear or
Skin.
only skin?
Well, because the skin's on the outside. So what happens is, I'll show you the picture here. Here is Summer.
Yeah.
Just look at me. Here is your cell, and inside your cell here is your DNA. Okay. So what happens is, yeah, the light comes in.
God, they become like Marvel or something.
No.
Changes.
The light comes in and maybe it hits an electron, and the electron becomes freed. Right? So then what happens is you have this electron going boing, 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 and if it hits here, it breaks the DNA. So then the cell becomes damaged, becomes a cancer cell.
Okay.
Now this isn't a big problem because every day your body finds cancer cells and removes them. However, if it misses this one, then it will begin to grow. So I think every day about 50 cancer cells are taken from your body. Okay, but like I said, if it misses one, then that's a problem. Yeah.
So how can I make sure?
So when you put on the sunscreen, it makes like a block. It reflects.
Okay.
It reflects the UV. So it makes less of it go in. This is the idea. So you can wear sunscreen or you can wear some clothes or whatever. Yeah. Yes. Look at you. Goodness. Right, what? Right. If you can... No. I want you to... There's 3 questions. I want you to do at least one question before you go.
Come on. Very easy.
English.
155.
Yeah, that was a long lesson. 1 hour and 24 minutes.
What's mean Sean?
Sean. So you know the verb shine?
Shine.
Yeah. So you have like shine and Sean, like past.